What's going on, guys? It's Ila Bailey here. I record stuff on YouTube. Check description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel, give me a big thumbs up to support it. And this is called count sorted vowel strings. Given an integer n, return the number of strings of length n that consist only of vowels a, e, I, O, U, and are lexicographically sorted. A string S is lexicographically sorted. E for all valid I, the value at the position of I in the alphabet is the same as or comes before the value at the position of I plus 1 in the alphabet. Okay, so let's look at those examples. Here we got n, which is 1. Okay, the 5 sorted strings that consist of vowels only are these letters. As you can see, every letter is considered as a complete string. Okay, here in this array we got 5, therefore return 5 as an output. Here we got n, which is 2. The 15 sorted strings that consist of vowels only are double A, E, I, O, U, double E, I, O, U, double I, O, U, double O, U, and double U. Okay, so there is no duplicate here. Every string is unique. Note that EA is not a valid string since E comes after A in the alphabet. Okay, by the way, we already got A. That's what I said. Ain't no duplicate here. Return 15. N is equal to 33. Okay, return this output. An integer is within the range of 1 and 50 inclusive. Okay, so we can solve this problem using dynamic programming. We can use a combination number approach. Okay, I'll show you both. As you know, guys, we can solve problems in dynamic programming using bottom-up approach and the top-down approach. The difference is generally, okay, bottom-up approach is solved using a tabulation technique, a tabulation method. Okay, and a top-down approach generally uses a memorization, which is the recursion. Okay, so I'll show you how to solve this problem using bottom-up approach, which uses a tabulation method. Yeah, so go for it. All you need is initialize an array. Okay, array is equal to generally in dynamic programming, when we use a tabulation method, the first value, the first number is equal to 0. Okay, when we initialize an array, and we start calculating the results, starting with the second, from the second value, which is here. Indices in Java start from 0. Okay, we got 0, 1, 2, 3, 4, and 5, right? as you know from the description of this problem, we got 5 vowels, okay. Therefore we have 5 ones in this array, okay. 1, 2, 3, 4, and 5, okay. Indices, yeah. So what we're gonna do is we are going to create 2 loops, okay. One of them is gonna be a nested loop, a nested one. The first loop represents the number of passes we're gonna have, okay. So we're gonna have n passes, okay. So we create a for loop int I is equal to 1, I is less than or equal to n, and I plus plus. The second loop, okay, we have int k is equal to 1, and k is less than or equal to okay, we got 1, 2, 3, 4, and 5. So we got 5, okay. We got 5 vowels, therefore we have 5 here, okay. K represents the position where we are, okay. K plus plus, and what we're gonna do is we modify the values at the position, okay, at the position of k, okay, the current position in this already initialized array R. So we say we add, okay, the previous value, okay, the value at the previous position to the value at the current position, by saying plus equal array k minus 1, and we are going to the next to the next value here. Then we do the same, we go here, we go here, here, then we increment I by 1, okay, and we go on, we start over, I would say here, but here, but we go on modifying those values in this array. And finally, when we talk about the dynamic programming, we think about the very last step, okay. So we return the value, the position of 5 in this array R. That's pretty much it. I think that's super easy, and I think that's pretty obvious what we are doing here. Let's run this code, okay. Oh yeah, okay, let's run this code again. There we go, accepted. Let's submit. First try, success, good. So the time complexity for this problem is big of n times k, where n is an integer, okay, or given integer, is given integer, and k is the number of vowels. Yeah, this is the first solution. Now I'm gonna show you how to solve this problem, you know, using another solution, um, which is a combination number approach. So we can solve this problem, I would say in one line, right? So there is a formula, okay, combination we're going to use that looks like this. We have you know, we have an integer n, okay, plus the position, okay, of the first number right after the first number, okay. For example, we're here, right, at the position of 0, right here. We got those vowels, indices 0, 1, 2, 3, and 4, right? For example, we are at the position of A, the position of 0. We start from the position of the first letter right after the first letter, okay, which is here. Yeah, we start from this point, right? So we say okay, so we say 1, right? Then we multiply times, n plus 2, okay, the second letter right after the first letter in this array, right? This is the first letter, this is the second one. I multiply, okay, by n, right, plus 3 we got, and so on and so forth, right? And finally we got divide by the number of vowels, okay, the number of vowels, minus 1 factorial. In this case we got 5 vowels, right? The number of vowels is equal to 5. So here we got the number of vowels, minus 1, okay, factorial, okay. So for example, we got 5 minus 1 is equal to 4. We got 4 factorial. 4 factorial is equal to 3 multiplied by 2 multiplied by 1 is equal to 3 multiplied by 2 is equal to 6. 6 multiplied 3 multiplied by 2 is equal to 4. 4 multiplied by 3 is equal to 12, right? 12 multiplied by 2 is equal to 24, right? And we got 24. We got 24. Okay, so we got 24, and 24 multiplied by you know, 1 is equal to 24, right? 12, 24, 1, okay, 24. So is equal to 24. Yeah. Here we got 24. Therefore, return return n plus 1 multiply by n plus 2, okay, and multiplied by n plus 3, okay. The position, okay, those are the positions of, you know, of those vowels, all those vowels right after the first one, okay. This is the first vowel, this is the second one, the third one, and the fourth one. Multiply by n plus 4, okay, and divide by 24 in this case, okay. Factorial 4 factorial is equal to 24. Yeah, that's pretty much it. Let's run this code. Okay, good, accepted. Let's submit. Yeah, success, nice. So the time complexity for this problem, the time complexity and the space complexity, okay, big of 1, which is constant, okay. We got constant complexities, so this is an optimal solution, I would say, right? But I think the solution that I showed, that I shown right off the bat, okay, but that solution was easier to to think, to understand, because we can do a lot of things using dynamic programming, and they are very obvious. Anyways, thank you guys for watching. Leave your comments below. I wanna know what you think. Follow me on social medias. Follow me on Instagram, add me on Snapchat, and I wish you all the best. Bye.